Hey Venus, I thought I could explain this better in a video rather than trying to write it out, so I'm going to shoot you a little link to this. So let me start with variable restrictions, the idea that we can't divide by zero. The trouble with dividing by zero, I'll just do a couple of simple little examples here. So say I have 6 divided by 2, that's going to make 3, right? And we can check our division using multiplication because that's its inverse operation, so 2 times 3 does really make 6, so that whole thing makes sense. If I try 0 divided by 3, that's cool, that's 0. 3 times 0 really does make 0. But when I try 3 divided by 0, there's nothing, everyone wants it to be 0, but if I go 0 times 0, it doesn't make 3s. That kind of tells me there's something happening here that isn't good with the division by 0 thing. And what ends up happening with that, if you try to divide by 0, it just keeps the number explodes to infinity. So if you try graphing something like 1 over x in, say, Desmos, which is an online graphing calculator, and you let these x values get closer to infinity, what's going to happen is, when x is 1, y is going to be 1. When x is 1/10, that would flip over and you would get a 10. If it was 1/100th, so I'm getting closer and closer to this problem at 0. Now the graph pops up to 100. But it can never be 0, it's undefined. So with that one, graph, just like as I approach 0, this just shoots up to infinity. It gets closer and closer to the axis, but it can never get there. On the other side, it ends up kind of doing the opposite thing. And so you just end up with this weird spot at 0 where, because there's no mathematical way to divide by 0, you can't have one thing split among nothing. So you get this kind of weird graphical behavior of these, what's called an asymptote. For what we're doing some stuff, so this is kind of the basic why division by 0 doesn't work. So in this problem, we have division by 0 trouble, because if right out of the gate, if I'm like, hey, I'm going to let x equal 2, then I would have, 2 squared is 4, 4 minus 4 is fine, that 0 is okay. But down here, I would get 2 minus 2, and that's division by 0, and that's what we just had down here, is not a cool deal. And so with this expression, we can factor and reduce it a little bit. If I did that, and that's kind of what we were doing in 8.1, it would look something like this, x minus 2. Then we cancel those, and then we get, the result would be x plus 2. If you think about what x plus 2 is, that's y equals x plus 2. That's just one of those linear equations we saw back on the first test. So it'd have an intercept of 2 and then a slope of 1. And so this expression, this is what we've been saying, x plus 2. This and this are the same thing. That's what we've been doing in 8.1, is simplifying this down to its simplest terms. Well, it's almost the same thing. If you graph this one and you graph this one, again, like in a graphing calculator or on Desmos online, the graphs will look totally identical. They're both going to look like this line, intercept of 2, slope of 1. But there's one difference, and that is, if I had the computer graph this one, this point would be filled in. If I have the computer graph that one, it's gonna, if I click on this point here at x equals 2, at that variable restriction, it's gonna tell me it's undefined. And when I draw the graph, I would have to put a hole right there, because at that point, there's no value that would make that true. And so that's the undefined. That's this weird thing that happens. So the variable restriction is saying this graph is exact same deal as this graph, except right here at x equals 2, it messes up, because if I put 2 into this, it says, hey, yeah, it's 4, it's totally defined, it's there. But if I put 2 into this, it comes out undefined. So these are equivalent expressions, except at the place where there's division by 0. So that's what the restrictions are about. So that's why you're doing it. So let me make up a couple examples real quick, just to talk about then, how to find them. So you're totally solid on the factoring, so I'm not going to bother to start a problem from scratch and just to get all the way down to the factoring piece. But basically, if I had something that was, like this, and up top I had something like that, say, we're going to cancel those 3's, right? But the restriction has to be relative to the original function, because that's why there's a restriction, is because we're doing this reduction and we're making a piece of the original function disappear. So over here, I would reduce this and I would get this as my answer, but for the restrictions, it has to be both pieces. So here we're saying x doesn't get to be 3, because that makes that one 0, and 0 times who cares, still 0. And then this x couldn't be 5, because that's what would mess that one up. So even though this would be the answer, these are the restrictions, because this one we can see, we can know that one's not going to be a problem, or this one is a problem because I can see it in the denominator still, but that reduction hit this one, and this is supposed to be the same thing as this. We have to call out the 3 and say, yeah, it's the same thing as 3, except not, or sorry, it's the same thing as this, except when x is 3. That's the only spot there's a problem. If the denominator was slightly more complicated, say, I just have 1 over just 2x minus 7, something like that. So for this, that's just that solve in case this piece got you at all. You bring the 7 over and divide out the 2. And so that's how it would be getting when it's not just a plain x, but something with a coefficient. And then I think you also wrote, there's 2 other things. So what if I have this, x squared plus 4? This is a good one. So this is kind of like, this is a little bit simpler version of the problem there is when you factor those cubes. And you know how I was saying with the cube, the first 2 terms, that will give you a restriction, but then the trinomial piece doesn't factor. And so this is another one that doesn't factor. If you try to factor this, you can't get it. And if you think about just trying to solve it, x squared would have to equal -4, right? Because -4 plus 4 to make that come out to 0. So if I think, well, what do I make x to make it come out to -4? And then it turns out there's nothing I can put in for x. Because if I do 2 squared is 4. So that's not, I can't make this -4 I need. If I put -2 in here, -2 squared is still 4, right? So I can't make this 0. It never equals 0. And so that's why this piece doesn't have a restriction, is it just doesn't have an answer that will make it turn out to 0. And it turns out it will have solutions. They're imaginary solutions, and we'll hit those at the end of chapter 9. But in terms of our restrictions, they don't come into play because they're not real zeros. So therefore, we're not dividing by 0. And then the last thing, what was it? Oh, you asked about multivariables. Okay, so here we go. Say I have x minus y, and I want to talk about what the restriction on that could be. It's not really meaningful because, think about if x is 1, then the only restriction on y is that it can't be 1. But if x is 3, then the restriction on y is it can't be 3. So like in this case, if I say x minus y doesn't get to equal 0, the restriction would be x, if I bring this y over, cannot equal y, right? Because if x and y were the same thing, then that would mean it was going to cancel each other out and go to 0. This is way beyond where we are in Math 98. And so this idea of figuring out what the multi-restrictions would be, they're always going to be something dependent on something else, not meaningful in what we're doing. And so that's why, and we don't even think of them as restrictions in this sense. Not that there aren't patterns, but not the same way that we're doing up here. So for this piece, no restrictions, because there's kind of an infinite number of things that can and can't work depending on how we define each variable. Okay, I don't know if that was more or less or hopefully helpful than you were actually looking for there, but hopefully that gave you some information on the restrictions. Cool.